Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. Now, we are doing Lesson 15, but we have already done Lesson 15's teaching video, and now we're doing Lesson 15's practice because the video was just getting too long to process. So here we are with the practice problems. This is practice A. So once you get the practice on your paper, you're going to pause your video. Okay, hopefully you did that. And right rectangular prism is what we call this. Remember, when the base is a polygon, then we call this a prism. And it is a right rectangular prism, so we know that the shapes are rectangular and the dimensions are in inches. So when we're doing the area, the surface area of the whole figure, we know on a right rectangular prism there are 6 sides to be accounted for. We have the front, and then we have the back. We have the top, and then we have the bottom, and then we have a side, and over there on the other side we have another side. So we have 6 sides that we have to take into consideration. We're going to find the area of each side, and then we're going to add them all together. So I like to find the area in 2s because I know the top is exactly the same size as the bottom of this figure. And remember, the top and the bottom are both called bases. So the top is, I'm going to erase that because that is not a number, and that is not a number. Okay, so this is a 3, which means that this side here is a 3. And since this bottom side is a 4, this side here is also a 4. So we have a 4 by 3 rectangle on the top. So the top and the bottom are both 4 by 3. And to find the area of each one, it's 4 times 3. And so we're going to have 12 and then double that because we have 2, both bases have that same measure. Okay, so then we look at the front and the back, and the front and the back, so we'll label this top and the bottom. We'll label this front and back. Okay, so the front and the back are both 2 by 4s. So 2 by 4. And so their area is 8, but there are 2 of them. So we'll write down 2 times 8. And then the side and the side, so we'll put side and side. And there are 2 of those, but we have this height here is 2. And this going back here is the same as here, which is 3. So we have 2 by 3s. And we have 2 of those. So 2 times 6, because 2 times 3 is 6. So now we have, these are the areas of each side that we're going to add together. And remember, since the dimensions are in inches, then our area dimensions will be inches squared. So we have 24 square inches, and we have 16 square inches, and we have 12 square inches. So when we add all of those up together, 10 plus 2 is 12, carry 3, 4, 5, 52 square inches is the surface area of this right rectangular prism. I hope you got the same answer. Okay, here are we back with example or practice B. So once you've copied down your figure, I would copy it from the book because they are neater than I am. Come back and I will show you how to work this. Whenever I see a problem like this, I think of cheese, because back when I was a little girl, we would often get our cheese in wedges like this. So I think of cheese when I think of triangular prisms. Isn't that funny? Now pause your video. Okay, so now let's look at this figure and see if we can kind of pick it apart. I recommend you look at your book because your book is easier to see than my very poor drawing. But I've done the best I can. It's just that I couldn't close this up because I ran into my other figure there. But we do have, on a triangular prism, we have 5 sides to take into account. So the triangular prism is sitting on a side, okay? It has a back side here, and then it has this face here, okay? And then it's got a triangle in the front, and it's got another matching triangle in back. So let's think of the area of the 2 triangles. So there's 2 triangles, right? One in the front and a matching one in the back. So we're going to have twice the area of the triangles, and then plus the area of 3 sides. Okay, so that's what we have to put together to find our surface area. Okay, so this side right here, the back side over here, and the side that it's sitting on are the sides, and then the front and the back triangular pieces. So let's find the area of the triangle first. We know that the area of the triangle, since we're going to have 2 of them, we'll say the area of the triangle is 1/2 base times height. But if I'm doing twice 1/2, why bother, right? Because twice 1/2, they're going to cancel out. So we're just going to find base times height. So base times height is 48. So the area of both triangles together will be 48. And that is done. And that's going to be in square feet. So now that we've found the area of both of the triangles together, we're going to find the area of each rectangular side. So this front side is rectangular, and it is 10 by 12. So that's going to be 120 square feet. Okay, and then the back side over here has 6 for the height, but then it's also got this 12 length here. So it's 6 by 12, or 72 square feet. And then the one that it's sitting on is 8 by 12, and 8 times 12 is 96 square feet. So I have all of the pieces here, and now I have to add, that's for 2 triangles, remember. I have to add 1, 2, 3, and then the 2 triangles together to make my 5 sides. So let's do the math there. We've got 48 and 72 will go together nicely, because the 8 and the 2 will make another group of 10. So I'm going to slide this 8 over here, make that 80 plus 40 is 120, plus another 120 is 240, plus a 96. So 240 plus a 96 is going to be, that's almost 100, so that's going to be 336 should be our answer. Check it over for me, but that's the 2 triangles, and each one of those is individual, so if I added correctly, our answer is 336 square feet. Okay, so this is practice C, and we have a right circular cylinder. Okay, so if we sat the cylinder up on its end, it would look like a very, very skinny, tall shape, but it would be a right circular cylinder. So we are going to find the surface area, which means that we're going to have to find the area of both of the circles. So 2 times the area of the circle, and then we're going to unfold in our mind that big, remember when we unfold the sides here, it makes a big rectangle, and the rectangle will be the dimensions of so rectangle that makes the lateral surface area here is going to be the circumference of the circle times the length of the whole figure. Okay, so we have length times circumference of the circle. So the circumference gives you this distance around, then I fold it out and I get 200 times the circumference. Remember, the circumference is 2 pi r, and the r is 20, so let's take the 20 there. Okay, and then 2 times 20 is 40, so we have 40 pi times the length, and the length is 200. Okay, so we have 200 And 40 times 200 is going to be 8000 pi. Okay, so that's the area that is the lateral surface area. Okay, so whenever we always think of our figures as sitting right, not rolling around on the counter. Okay, so this right here is the lateral surface area, the area around, and it's 8,000 pi. Okay, so now we're going to have to, I'm going to lower this just a little bit so you can see the board. Okay, so 8,000 pi, and so that's this distance around. So we're going to say this is 8,000 pi in area. And then our area of the circle is pi r squared. And we're going to have that twice. So pi r squared, and then 2 times that because there's 2 circles, the top and the bottom. And the r is 20. So when I square 20, I'm going to get 400. So I'm going to get 400. This is 400. And 400 times 2 is 800. So 800 pi. And that's already been doubled, okay? So the 800 pi is for both of them, okay? So this was 400 pi, this was 400 pi. So together, they give me 800 pi. And I have 800 plus 8,000. So 8800 pi. Okay, now let's see. Did they tell me to leave the answer in pi or to go ahead and multiply it? Since they didn't tell me, I'm probably going to leave it both ways. I'm going to leave it the exact answer, which is 8,800 pi. Okay, but then when I substitute in 3.14, I will get an approximate answer. Okay, so I'm going to let you do that. I'm just going to show you how to do this. So the answer is 8,800 pi, and now to get the approximate answer, you need to multiply by pi. I'll let you do that. Okay? Hopefully you understand how to go about finding the right circular cylinder surface area. Okay, I thought it would be best to show you a picture of this last practice problem. This is D, and I want you to go ahead and copy it on your paper, and then I will show you how to do it. But since it's a very odd shape, we just call it a right solid, and it is 10 meters high, and the base is what they're showing you down here at the bottom. So this is the base and the shape of the base, and also the shape of the top. Remember, the top and the bottom are both called bases. And then we've got to think about this lateral surface area all around the sides. So make sure you pause your video and go do that problem so that you can see if you get it right when I do it for you. All right, hopefully you paused your video like you were supposed to. And this is the last practice problem on set 15. Then you need to go do your homework. So we're talking, this is a right solid, and it can't be named anything else because it's so weird. It's just a right solid. So when we're talking about a right solid, we will have to find the area of the base. And since the base and the top are both bases, they're both the same size, we're going to say twice the area of the base will be in our total area. Okay, so we have to take the area of the base and then double it. Then we're going to take this lateral. Remember, when we unpeel this whole side, it becomes a long rectangle. So then we unpeel the whole lateral surface area, and the lateral surface area is perimeter of the base times the height. Okay, so I have that formula over here on the side. Lateral surface area, perimeter of the base times the height. So we have to find not only the area of this base, but also the perimeter to be able to use in the lateral surface area. So they said the base here was 10 meters, so we know that the height is 10 meters, so we can take this height down here and go ahead and put in 10 meters because we know that. So now let's look first at the area of the base. So we have a triangle, and then we have a half of a circle. So the triangle is 1/2 base times height. They don't give us the height, but we can figure out the height because this 3 here is a radius, which means this one is 3 and this one is 3. So that whole side is going to be 6. So we have 8 times 6 is 48, but then a triangle is half of that. So the area of the triangle is 1/2 base times height. So 6 times 8 times 1/2, which is going to be 24. So the area of the base is 24 square units, and then we will double that. Okay, so we'll just leave it like that. Then we have to find this perimeter. Oops, we only did the triangle, didn't we? We did the triangle as 24. I was getting ahead of myself. Now we have to do the little half a circle. The half a circle is, remember the area of a circle is pi r squared, but that's a half a circle, so it's pi r squared divided by 2. So r is 3, so it's going to be 9 because 3 squared is 9. So we have 9/2 pi is this right here. Do a little arrow there. So we have 24 plus 9/2 pi is the area of the base, but then we're going to double that. So let's just double each one and add them together. So this one, when we double it, because we have 2 of them, is going to be 48. So we'll write that over here, 48 plus, and then we're going to double the 9/2 pi. But when we double something that's been split in half, then we can just nix that out and get 9 pi. So the doubled area is 48 plus 9 pi. We're going to have to do a little bit of cleaning up on that, but this is the area of the base doubled. Okay, so we'll just do a little arrow right there showing twice the area of the base is right there. Okay, so now we need to find the perimeter of this whole figure. Well, I know this is 8, I know this is 10, and this right here, perimeter, I'm going to go ahead and erase this. This was 9/2 pi, and I'm going to stick 9/2 pi inside just so we remember what it was. 9 pi over 2. And now we're going to find this right here, which is the perimeter of the figure, which is when we're talking about a circle or even a half a circle, it's the circumference right here. Okay, so the circumference is the distance all the way around. The circumference of a circle is 2 pi r, but we have half a circle, so won't we just cut that in half? So the 2 divides by the 2, and this should be just pi r. So since that is pi r and r is 3, won't this here be 3 pi? And that's right. So now our perimeter is 10 plus 8 plus 3 pi. And the perimeter right here is going to be 18 plus 3 pi. So let's take perimeter of the base, and right here we'll write 18 plus 3 pi. Okay, and then the height we already said was 10 meters. And so we're going to multiply these together, and we'll put that right here. Okay, so we can distribute, can't we? 10 times 18 is going to be 180. And then 10 times 3 pi is going to be 30 pi. Okay, so now this one was from our 2 bases, and it's here. And then this one is our lateral surface area, and it's right here. So now to find the whole shebang, shouldn't we add these 2 together? So 48 plus 180 is going to be 228 plus, and then we have 39 pi. Okay, so now we would need to add these together, but before we can add them together, we would need to substitute in 3.14, multiply the 39 times the 3.14. I'm out of room, so I'm going to do this one for you on your calculator and give you a final answer, but this is the exact answer. right there, just like that. 228 plus 39 pi is the exact answer, and I'm going to go to my calculator and give you an approximate answer here, but this one is the exact answer. Okay, so I went and calculated and got 350.46, and that is going to be, they say the dimensions are in meters, so that is going to be 350.46 square meters. Okay, now let's just recap this whole problem because it's kind of a big one here. Okay, so we had to find this area twice, right? So twice the area of the base. We found the area of the triangle was 24. We found this area over here was 9 over 2 pi. Then we said, well, we've got to double it. So the 24 times the 2. So 24 plus 9 pi over 2 is the area of the base. But then we doubled it. We got 48 plus 9 pi. So this is the area of both of the bases together. And then we had to unpeel that whole thing, which was perimeter times height, perimeter of the base times the height. We said, okay, the 10 plus the 8 is the 18. We figured out this was 3 pi. So this was the perimeter of the base times the height of the figure. We distributed that out to get this. We added these together to get this. This was our exact answer. I put this on a calculator, multiplied this by pi, and then added the 228 and got this one. And that is the end of lesson 15. And this is Mrs. A, and may God bless your day.